Hi, everybody. Welcome to Math with ACE. We are focusing on statistics today. We are specifically working with the analysis of variance one way here. And what we're going to do is we're going to work through an example problem, and I'm going to be using Saplet to help with our calculations and also checking our conditions. So let's get into it. A researcher wants to compare the mean study time per week for students using 3 different types of course materials: printed textbook, ebook, and instructor-created videos. A random sample of students is selected from each group. The weekly study times and hours are shown below. At the 5% level of significance, test whether there's a difference in the mean weekly study time amongst the 3 types of course materials. So as we are comparing the 3 different types of course materials for the mean weekly study time, that means we have 3 different means that we're comparing. So our null hypothesis is going to be mu1 equals mu2 equals mu3. You could also see mu-t, mu-e, mu-v, like for instructor videos, ebook, and textbook. And then our alternative hypothesis is that at least one of the means is different. We also want an alpha equals 0.05 level of significance. And we need to define that mu1 is the true population mean weekly study time for students using a printed textbook. And then for sake of speed, I'm going to say that mu2 and mu3 are the population mean study time for students using A. 2 is going to be ebook, and 3 is going to be instructor videos. This is just me using shorthand. I would say if you're doing this on a test or if you're doing the AP exam or any of those things, you want to write out what the parameter is. So now we need to check our conditions. And in order to check conditions, what we need to do is determine whether the samples were random, independent, large, and have equal standard deviation or equal variance is what we call that condition. So for random, we are told that the students were randomly sampled. Scroll down just a little bit. And then for independent, we need to determine how many students there are. We have 1, 2, 3, 4, 5, 6, 7, 8, I believe 24. So independent, we have 24 times 10. We need 240 students in the population. So I think it's safe to assume that there's 240 students when we're talking about a teacher with their students. Okay. So I'll scroll down. That says students, I need 240 students, so it's safe to assume that there are 240 students. And then when we get to the large counts condition, for means, I am going to scroll back up. I can meet this in 3 ways. One way is that the population is stated to be normal, but nowhere in this problem am I told that. Our sample size could be at least 30. These different groups do not have 30 in them. So I need to graph the data. So in order to do both the large counts and the equal standard deviation, equal variance, and condition, we need to look at the data. So I'm going to go to one quantitative variable, multiple groups. And in this case, we are talking about study time per week. And the first group was printed textbook. The second group was ebook. And the third group was instructor videos. hoping this copies over. Excellent. Oops. Okay, so now we're going to begin analysis. And if we look at our dot plots, we don't really see any outliers or skewness. Let's look at our box plots. They look really good. So what I'm going to say for the large counts on the left is that none of the 3 box plots show any strong skewness or outliers. Which means we're good to go for that. Now we look below at the chart of the data to see what the smallest standard deviation is. And that is 0.2. The largest standard deviation is 0.245. So is 0.245 less than 0.2 times 2? Yes, 0.245 is less than 0.4. So we're good to go there in terms of whether we've met the equal variance, or that equal standard deviation, as we're calling it, condition. And I'm just waiting for my writing to catch up here. So all of the conditions have been met. What we can do then is we can look at performing our calculations now. And in order to perform our calculations, what we need to do is run a F-statistic or do an ANOVA test. So back in Statlet, we're going to scroll down, and I already have one way ANOVA preloaded. I click perform inference, and I'm given the standard deviations, or the degrees of freedom for the numerator and the denominator, about the variance between the groups, within groups, and inside each group. Between and within is what they call them. So between the 2 groups and within each group are the degrees of freedom, and that's what the standard deviations we're comparing in the numerator and denominator. So we have an F value of 200.375 and a P value of less than 0.0001. So knowing what we know about P values, this is very, very small. This means that if the means really were equal, then there is a very small percentage of obtaining the sample data that we did purely by chance, assuming that that was true. So the data that we did are data more extreme. So it's not likely. So what we can then say is, since our p-value of less than 0.0001 is less than our alpha equals 0.05 level of significance, what do? We reject the null. So that means that there is sufficient evidence to support the claim that at least one mean is different. So now again, for us and the scope of the class that I teach with intro, we don't get into the actual calculation of the F-statistic. It's more about the interpretation and understanding that you're comparing the different means, more than 2 of them. So hopefully this was helpful. Thanks for watching.